Okay. So 1.25. How much?
Hold on.
Yeah, the approximation so we can compare to -1.
Yeah, -5/9. Or 0.55555.
Good. Okay, that's what it is. For this particular function, that's the difference. The exact difference is -1. The estimate is -0.55.
The exact is -0.55, right?
That's the exact.
Yes.
Our estimate, boom, boom, quickly, with dy is -1. Is that okay? Clear? Okay, perfect. Moving on, differentiate implicitly to find this. And then find the slope of the curve at the given point. They're not asking us to find the equation of the line, just the slope. So we have xy plus y squared minus 2x equals 0. We're asked to find dy over dx and then evaluate it at this point. So when we're asked to find dy over dx, what does this say? Automatically it tells us that y is a function of x. Excellent. Good. So let's differentiate. We cannot solve this for y. So let's differentiate the left and differentiate the right. Please tell me what to write. To get this, I have to use the product rule here. First function prime is 1 times y plus the first function times the second prime, which is dy over dx, plus. Very good. Times dy over dx minus 2 equals 0. And as we know, we are after this piece. So I'll have to move everything else to the other side, and I will factor out. So x plus 2y dy over dx equals 2 minus y. I moved 2, it became positive. I moved y, it became negative. So then dy over dx equals 2 minus y over x plus 2y. And they're only asking us to evaluate when x is 1 and when y is -2. Any questions before we evaluate? Any questions before we evaluate? So ready to evaluate? So the top is 2 minus -2. So the top is 4. The denominator is 1 minus 4, which is -3. So the answer is -4/3 will be the slope of the tangent line to the graph of whatever this is at this point. The slope will be -4/3. Any questions? Any questions? Is this okay? Any questions here? Okay. On the next problem we're given 4 pi over 3 r cubed. That's the volume of a sphere. The radius is growing at a rate of 0.7 centimeters per week. What will you say? What does this mean? 0.7 centimeters per week. It says the radius is growing at a rate of 0.7 centimeters per week. What does this mean? Right, so how do I write it? Perfect. dr over dt. Awesome, great job. How fast is the volume changing at that moment? When the radius is 7.5 centimeters. Remember, when you see this word, whatever follows after it, it has to wait. until the end. Do not plug it in at the beginning. That's an instant. That's like a particular moment, right? So we have the volume. We are given the rate of change of the radius. And the question is, how fast is the volume changing at that moment? So what do I have to do? Very good. So remember, the function v is a function of time. So I can find dv over dt equals. What do I write on the right-hand side? 4 pi r cubed. I meant to say squared, of course. 4 pi r squared times I already simplified with the 3 in the denominator. R squared times.
Wait, why is it squared?
I bring down 3. I subtract 1 from the power. I bring down 3, subtract 1 from the power, times,
Oh. 3 pi
times,
squared
times,
dv over dt.
thank you, dr over dt. Very good. Times the inner function prime. I have everything I want. It says radius is 7.5 centimeters. And when dr over dt equals 0.7 centimeters per week. And that's it. 4 times pi times 7.5 squared times 0.7. And I'm waiting for you to give me the measurement unit, and I can calculate this, but I need the measurement unit. So it's 4 times pi times 7.5 squared and times 0.7. And I got 494.8. Measurement unit, please.
Centimeters per week. Right? Or volume, oh, I'm sorry, that is cube.
Yes, cubic centimeters per week. So let's analyze what this means. It means this, that the fruit is increasing in volume, and the radius is also increasing. So at the moment, at the instant in which the rate of change of the radius with respect to time is 0.7, the volume at that instant, and when the radius is 7.5 centimeters, at that instant, the volume changes by 494.8 cubic centimeters per week. Any questions? Is that okay? It was a pretty simple problem, wasn't it? We agree?
Yes.
Perfect. Okay, so the extra credit, the cube root of 1,002. It says approximate or estimate, if you want, using differentials. Remember, the formula is, this is approximately f of x plus f prime of x dx. I'm hoping that you are going to write this down several times and commit it to memory, because we used it several times in the last few weeks. So I have to identify a few things. I have to identify f of x, I have to identify x, I have to identify dx, and of course I have to calculate f prime of x. So let's start with the easier part. Can anyone give us x? Something nice, something close, something that we can take the cube root from. Of course. Can anyone then give us dx? The error from 1,000? 2. which function was used? That's it. So then the derivative is going to be, so remember this is x to 1/3. So this is 1/3 x to negative 2/3. We have all the pieces, we just have to put them together. And that is it. So this now I can write equals. Here I have to write this approximation symbol. But now I'm evaluating this and I can write the equal symbol. So f of 1,000 means the cube root of 1,000 plus f prime of 1,000 means 1/3 the cube root, or 1,000 if you want, raised to negative 2/3. And dx is 2. So how much is the cube root of 1,000? 10. The cube root of 1,000 is 10. But that will be plus 1/3 the cube root of 1,000 squared times 2. So this is 10 plus 2/3. The cube root of 1,000 is 10 times another cube root of 1,000, another 10. So this is 300. So this is 10 plus 1/150. Or when you multiply 1,500 plus 1. This is a very good approximation of the cube root of 1,002. So now if you'd like to check, and we should always check, right? So let's do that. 1,002 raised to power 1/3. That's the cube root, or you can use other ways, of course. That's 1. And 1,501 divided by 150. It better be very close, because we used calculus to determine it. It's very close. You had no idea that you could determine the cube root of a number using calculus and get just a simple fraction and get such a good approximation. That's how they did it before they invented calculator. They used calculus to determine that. And before they, they knew how to take the cube root, of course. I don't know actually which one came in first. I don't want to. I have not investigated it. If they found out how to determine the cube root of a number first, or they used calculus. That's a good question. Now we still have a few minutes. I would like to go back to a problem or problems that you say, I need to see another problem like that. Anything that you would like to go back to. Any questions you may have. Any type of problem. So we decided that our test is a week from today, which is the 9th, right? Okay. So this is test 2.
Are there any questions in chapter 3?
Anything you want. Yes.
Okay, so like what do you consider? Nothing from chapter 3 is on this, right?
Yes. So let's take a look at chapter 3. Very good question. Excellent. Excellent question. From chapter 3.
So there are going to be chapter 3 questions?
Yes. 3:1 through 3:2 and 3:3. Yes. What I could ask from chapter 3 is a problem like, let's say, what we did in class. Nothing else but what we did in class. So if you look on page 321, we did a problem about forgetting. Let me just list so you can look at all these are odd number problems. So let's say 103 on page 320. We did those in class. That's a question. That's a possibility. Another problem, for example, like 39. We did that in class too, 304. Or like 53 on 304. So that's from 3.1. From 3.2, I already picked the problem, so let me pick another. Derivative. We differentiated everything. If you'll see it in your notes. 88 on 319. We did also 86 and 85 in class. 85, 86 on 319. That's pretty much. And let's look at 3.3. In 3.3, we did yes, something like, I think we looked at the spread of infection, isn't it? Yes, 47 on 335. I'll make sure that a problem like number 1 that we had on this test is not going to happen. This test was a 2-hour test, however. So not la problem 1, la problem 2. Only because it takes so long. It took us together. Oh, we had to do it twice only because we had an error in copying, but not because it was nothing. But still, it took a long time to determine and simplify the first and the second derivatives. Right.